Assalamualaikum. Now, the next lecture. अभी just we have completed with a concept of wavefront. और जो diagram आपने देखा था बना हुआ था, it's very complicated. But those who have a concept, they can easily graph what actually given in the diagram. So, अब कोई भी आपसे पूछे what is a wave, what is a ray, and what actually wavefronts are, now you can easily answer. So, what is actually wavefront? It's an imaginary line and can be defined as locus of all the points on the wave which are in the same phase. We are done with that. Now next is, first let's take up with a very important mathematical form जो कि wave motion को represent करते हैं. It's the equation of wave, or we call it wave equation. It's a simple formula. V is equal to lambda f. V stands for velocity, lambda stands for wavelength, and f stands for frequency of the wave. How it is derived? There are 3 to 4 steps. Let's see, and then that you will be asked a number of questions in your exams regarding using this equation, which is called wave equation. So let's derive that expression. So we can place a heading. What we are deriving at the moment, it's a wave equation. Wave equation. How it is derived? D-E-R-I-V. Derive means to extract. It's not deriving a car. Derive. From where we can derive this equation? We can derive this equation from any general concept. And what the general concept is? So we know that. We know that. हमें पहले से एक चीज पता है. What we know है? We know that speed is equal to distance upon time. So आपको पता है, speed is equal to distance upon time. It's a general equation of motion. In terms of wave motion, अगर मैं इसको लिखूं, in terms of wave motion, so definitely जो ये terms हैं, इसको मैं wave motion में जो term use किया उससे replace कर दूंगा. Speed, whether a car is moving or a wave is moving. Speed represented with the same symbol, it's V. Distance, when we talk about a distance in wave, so wavelength actually represents the distance. So we can replace this distance with wavelength. It's a Greek symbol lambda. Time, kahin pe bhi jao, time is time. So, this case mein time bhi kya rahega? T. So, this equation, speed is equal to distance upon time, which is the general equation of motion. In terms of wave motion likhu, so I can replace these terms with symbol V, same in when we are talking about a linear motion or wave motion. Distance in case of waves is represented with the wavelength, and time. Again, in a time of one period, what period is? It's actually time period denoted with capital T. What is time period, or what is period? It's a time required to produce one wave. एक wave produce करने का time. अगर मैं इस equation को, जिसमें time कितनी भी waves की production का हो सकता है, but अगर मैं इसको precise कर लूँ किसके लिए? In a time of one period for the production of one wave. So this time will become a time period, and when it becomes time period, so this V is equal to lambda upon small t will become V is equal to lambda upon capital T. When we are talking for the production of one wave, when one wave is produced, it's called what? A time period. We all know 1 upon t, the reciprocal of time period, is actually the frequency. What is the relation between frequency and the time period? They are reciprocate to one another. Reciprocal ek dusre ke. So, in place of 1 upon t, what I can write? I can write f. Therefore, V is equal to lambda. वही रहेगा. 1 upon t की जगह क्या लिख सकता हूँ? F. This is your wave equation. So, you are asked a number of questions using this equation, which is called a wave equation. V is equal to lambda f, where V shows velocity of the wave, lambda, it's the wavelength, and f is the frequency of the wave. And what is frequency? It's the number of waves produced in 1 second. So this was a brief equation to be proved under the heading wave equation. This equation should be on your fingertips. So whenever anyone asks you about a wave equation, it's V is equal to lambda f. The number of problems are being asked using this equation. So we are done with this. Now, next I will proceed further. Ripple tank, how it works. Last lecture के अंदर मैंने आपको explain किया था. The ripple tank in laboratory helps us to produce waves and helps us to study the properties of the waves. So let's draw a diagram for that ripple tank. Though it's not easy to draw. It's not as in exams कि आप draw करो, but हम draw करके साथ साथ आपको समझ आता रहेगा how it works. And then we will discuss when waves are produced in the ripple tank. So what you will be using to produce plane wave fronts and what you will be using to produce spherical wave fronts. And next, when these waves travels from deep water to shallow. Now what the deep and shallow is, how this equation behaves. What will happen to the wavelength, what will happen to the velocity, and what will happen to the frequency. Now let's start. Ripple tank. It's a very useful apparatus used in laboratory to produce waves and to study the properties of the waves. How it looks like. It consists of a shallow glass bottom tray. If I draw it, just to start, it's a ripple tank. How it looks like. Why I'm drawing this in front of you? Because if you get the diagram in your exams, so वो आपको problem ना करे. So let's draw a bit of a three-dimensional diagram that is definitely going to help us out studying the wave motion. Okay. So इसको three-dimensional work करने के लिए कुछ इस तरीके से करते हैं. तो quickly आपने three-dimensional work करने के लिए like this. थोड़ा सा quick work. Okay. It consists of what? It consists of a shallow glass tray. Shallow means it's not that deep. To show, it's a tray with little depth. You can draw it like this. So it's a bit deep, like this. It's mounted on 4 legs. Definitely, otherwise it will topple. Like this. It's a ripple tank. Ripple tank used to produce plane wave fronts, spherical wave fronts. For plane wave fronts, क्या होना चाहिए आपके पास? You are given a straight dipper which is placed like this, and if you need a spherical dipper, so it is also shown के इस तरीके से it's given. ठीक है? This dipper can move up and down with the help of a motor. यानी ये dipper ऊपर नीचे move करेगा up and down, or you can use this spherical dipper up and down. Like this. Waves are produced. You all know how waves are produced. They are produced like this. How wave fronts are produced. They are produced like this. Beneath this glass tray, a paper sheet is placed so that the image of wave produced in this shallow glass tray, image is obtained here. So you get number of like this shaded lines. These shaded line shows how actually waves are produced. Yani, when we talk about how this ripple then actually works, so I have drawn this diagram in front of you so that each and every part is explained perfectly. So it's a shallow glass tray. इसको कह सकते हैं? It's a shallow, more precisely glass bottom tray. Underneath this tray, you are placed a plain sheet which can behave like a screen. Whenever waves are produced in the water, you can get the images formed on that screen. You have straight dipper or plain dipper. For example, right now I'm talking about a plain dipper. So this is what? A plain dipper connected with the motor, and we talk about this is spherical dipper. If you have a spherical dipper, you will be getting spherical wave fronts. If you have a plain dipper, you will be having plain wave fronts. So right now what I have discussed, plain wave fronts. So how they are produced? So hope you have an idea. So this is how. Okay, we were discussing if I place the glass slab in this ripple tank, so how those waves will behave. So you can discuss this under the heading effect on wave when moving from deep water to shallow water. So इस वाटर में शैलो रीजन क्रिएट करने के लिए we will place one of the glass plate. तो अगर मैं इसका साइड व्यू देखूं, इस रिपल टैंक का, तो कुछ ऐसा होगा. ये रिपल टैंक था, like this. इसमें वाटर है. I have placed glass slab जिसने shallow portion क्रिएट कर दिया. तो मैंने ऐसे glass slab रख दिया. कि हम रिपल टैंक का साइड व्यू देख रहे हैं. Now, हमारे पास this is now the shallow portion and this is the deep portion. So ये deep portion मिल जाएगा हमारे पास. और ये हमारा shallow portion हो जाएगा. Now this is the shallow portion, right? And this is your deep portion. Now when ray or wave, which is produced from a straight dipper, travel from deep portion to the shallow portion, how it behaves? When it travels from the deep portion, wave is like this. And when it is traveling from the shallow portion, wave is like this. Matlab, when it is traveling from the deep portion, it has a wavelength. We may say this wavelength is lambda 1. This is long wavelength. And when it travels from deep portion to shallow portion, wavelength shortens. So, ये आ गई आपके पास wavelength lambda 2. And what this diagram is actually telling us that whenever a wave is traveling from the deep portion to the shallow portion, lambda 1, the wavelength of the wave in the deep portion is greater than wavelength of the wave in shallow portion. यही काम अगर मैं side view के बजाय aerial view करूं from the above. So we have number of wave fronts these wavefronts will behave like this. And these are the wavefronts from where we have started the shallow portion. From here, you will be getting waves with shorter wavelength like this, right? Like this. इसका मतलब है this is deep water. The wavelength is lambda 1. This is a shallow water. Wavelength is lambda 2 and lambda 1 is greater than lambda 2, और इसको हम कह सकते हैं scenario view. Aerial view means it's from above. So what conclusion we get? So whenever waves travels from deep portion to the shallow, wavelengths में फर्क क्या आएगा? वो long wavelengths से short wavelengths हो जाती है. And what will happen to the velocities? We have an equation, v is equal to lambda f. So velocity and wavelengths को अगर हम link करें, if we have short wavelengths, so velocity gets slower. And if you have long wavelengths, velocity of the wave is faster. So हम लिख सकते हैं कि the wavelength shortens. यहाँ पे क्या हो गया? Wavelength shortens. And what about the velocity? Velocity decreases. And when we are traveling in deep water, we have long wavelength and comparatively is traveling with greater speed. It's greater velocity. यहाँ पे velocity it's v1, यहाँ पे velocity it's v2. The same v1 greater than v2. This is how we discuss effect on waves when they are moving from deep water to shallow water. So हमारे पास जो long wavelengths they become shortened. और यहाँ पे अगर हम show करेंगे velocity wise और wavelength wise, so they are shown like this. Hope you understand what is the effect on waves when these waves are traveling from deep water to shallow. और ripple tank के अंदर ही हमने इसी चीज को study किया. So equation was v is equal to lambda f. So what we have discussed so far, what will happen to the wavelength when they are traveling from deeper to shallow, deep से shallow water में. तो conclude किया क्या? Deep water में they are moving with greater velocity and they have long wavelengths. And when they propagate to shallow portion, wavelength gets shortened, short wavelengths, and they move with less velocity. What will happen to the frequency? कहते हैं frequency depends upon the source. So we have the same source which is producing these waves. The frequency is unchanged. So frequency is unchanged. Why? Simple answer, because we have the same source which is producing these waves. So having the same source, the frequency is unchanged, whereas velocity and wavelength will change respectively. How it will change? So definitely you have an idea कि किस तरीके से वो change करेंगे. तो deep water में wavelength long, they move with greater velocity. Shallow water mein, velocity decreases and the wavelength shortens. What will happen to the frequency? It's unchanged because frequency actually depends upon from its source those waves are emitted. So this is a brief introduction about ripple length. Hope you have an idea so you can solve a number of questions regarding this concept. In next lecture, I will be discussing how these waves are refracted and reflected. And again, to observe this phenomenon, we'll be using what? A ripple length. Okay, so just next lecture, let's go work out here. Hopefully, I will understand that. Take care.